Ever wondered what preformulation is and why it's important in pharmaceuticals? Well, let's dive into this intriguing topic. Preformulation, in the simplest terms, is a stage of drug development where the physical, chemical, and mechanical properties of a drug molecule are studied. It's a crucial part of the pharmaceutical process because it lays the groundwork for how the drug will be formulated. By understanding the nature of the drug substance, scientists can predict how it will behave when mixed with other components. This knowledge helps them determine the best way to deliver the drug and ensure its stability, effectiveness, and safety. Whether it's determining the drug's solubility, its dissolution rate, or its compatibility with other substances, preformulation plays a pivotal role in these assessments. It's like a detective work, where scientists investigate and understand the characteristics of a drug molecule before it gets formulated into a medicine. So, you see, preformulation is the backbone of pharmaceutical formulation and development. Now that we know what preformulation is, let's dive into its parameters. Preformulation is like the dress rehearsal before the big show. It's the stage where we examine and understand the physical, chemical, and mechanical properties of a drug. Each of these parameters plays an integral part in the formulation and stability of the drug, impacting how it performs in the body and its shelf life. First up, we have physical properties. Think of these as the physical characteristics of the drug. These include attributes like color, size, shape, and density. How a drug looks and feels can greatly influence its acceptability and usability. For instance, a drug with a pleasant color and shape may be more appealing to a patient, while a drug with a high density might be harder to dissolve in the body. Next, we dive into the chemical properties. The chemical properties of a drug tell us about its chemical stability and reactivity. This is crucial as it influences how the drug interacts with the body and other substances. For example, a drug that is chemically unstable may degrade or react unfavorably when mixed with other substances. This can lead to reduced effectiveness or potentially harmful effects. Last but not least, we have the mechanical properties. This refers to the drug's resistance to various forces like compression and tension. These properties are important to consider when designing the drug's final form, whether it be a tablet, capsule, or injectable. A drug with good mechanical properties is more likely to withstand the rigors of manufacturing, storage, and usage without breaking down or losing its effectiveness. These three parameters are like the holy trinity of preformulation. But remember, they don't exist in isolation. They interact and influence each other in complex ways. For instance, a drug's physical properties can affect its chemical stability. A drug with a large surface area, due to its physical properties, might be more prone to chemical degradation. Similarly, the mechanical properties can impact the physical properties. A drug that is mechanically weak might break down into smaller particles, changing its physical properties like size and shape. Therefore, it is crucial to consider all these parameters in tandem to ensure a successful formulation. Think of it like baking a cake. You need to consider the physical properties like the size and shape of the ingredients, the chemical properties like how the ingredients react when mixed together, and the mechanical properties like how the batter holds up when poured into a pan. Just like in baking, in preformulation, the right balance and interaction of these parameters can lead to a successful and effective drug. These parameters play a vital role in ensuring the effectiveness and safety of the drug. So next time when you take a medicine, remember the intricate dance of these parameters that have come together to bring you that little pill or syrup. It's not just a drug, it's a marvel of science and engineering. Ever thought about the role of solubility and dissolution in preformulation? These two parameters are the unsung heroes in the world of pharmaceuticals, playing a pivotal role in drug absorption. Let's start with solubility. This is the ability of a solute, in this case our drug, to dissolve in a solvent. In the human body, the solvent is typically body fluids, like blood or stomach acid. The more soluble a drug is, the more easily it can be absorbed into the bloodstream and transported to where it's needed. Now, it's not just about how much of a drug can dissolve, but also how fast it can dissolve. That's where dissolution comes into play. Dissolution is the process by which a solid drug dissolves. Faster dissolution rates can mean faster onset of drug action. But here's the catch. An increase in solubility doesn't always mean an increase in dissolution rate. Various factors, such as the physical and chemical properties of the drug, can influence this. For instance, drugs with a high melting point, or those that form strong crystal structures, may have slower dissolution rates, regardless of their solubility. So, how does this tie back to preformulation? Well, understanding the solubility and dissolution characteristics of a drug helps formulators make critical decisions. For example, they might choose to modify the drug's physical form, like creating a salt form of the drug to improve its solubility. Or perhaps they might select specific additives to enhance dissolution rates. Ultimately, solubility and dissolution affect the bioavailability of a drug. Bioavailability refers to the extent and rate at which the drug reaches the systemic circulation. A drug with poor solubility or slow dissolution may not reach therapeutic levels in the body, making it ineffective. So, as you can see, understanding solubility and dissolution is crucial for the successful formulation of a drug. It's all about finding the perfect balance to ensure the drug can dissolve and be absorbed efficiently, doing its job of helping patients feel better. Stability is a key factor in drug development, but why is it so? Well, let's take a closer look. Stability studies are an integral part of preformulation, the stage of drug development where potential drug candidates are evaluated. These studies are crucial as they help in predicting the shelf life of the drug, ensuring its safety and maintaining its efficacy over time. So how does this work? Stability studies involve exposing the potential drug candidate to a variety of conditions such as different temperatures, humidity levels, and light exposure. The drug's physical, chemical, and microbiological stability are then observed and recorded. The physical stability refers to the visual aspects of the drug, like its color, shape, size, and texture. Any change in these parameters could indicate a problem with the drug's stability. Chemical stability, on the other hand, is about the chemical integrity of the drug. It's essential to ensure that the drug does not degrade or react with other substances over time, as this could impact its therapeutic effectiveness. Microbiological stability is equally important. It ensures that the drug does not support the growth of bacteria, fungi, or other microorganisms, which could prove harmful to the patient. These stability studies provide a wealth of information about the drug's behavior under different conditions. They help in selecting the optimal formulation and packaging, and also aid in establishing storage conditions and shelf life. In a nutshell, stability studies in preformulation are like a stress test for the drug. They help to ensure that the drug remains safe, effective, and unchanged under various conditions, providing assurance to both the manufacturer and the end user. So, the next time you pick up a medication from the pharmacy, remember that it has passed through rigorous stability tests to ensure that it remains effective and safe for you to use. Stability studies provide valuable insights into the long-term performance of the drug. They are a testament to the meticulous work that goes into ensuring the safety and efficacy of the medicines we use every day. Additives are often used in drug formulations, but what are they and why are they used? Let's dive in. Additives are substances that are added to drug formulations to enhance certain properties of the drug. They don't have therapeutic effects in themselves, but they aid in the delivery and effectiveness of the drug. These can range from improving the drug's stability and solubility to enhancing its taste or appearance, and even to controlling its release into the body. For instance, consider binders. These are additives used to hold the ingredients of a tablet together, preventing it from breaking apart before reaching the target site in the body. Common examples of binders include substances like acacia gum and cellulose derivatives. Then we have disintegrants, another type of additive. These are designed to break down the tablet within the body, ensuring the drug is released quickly. Starch is a commonly used disintegrant. Coloring agents are another category of additives that improve the visual appeal of medications. These agents, like titanium dioxide, can help distinguish different medications and dosages. Finally, let's talk about flavoring agents, used to mask the unpleasant taste of some drugs, making them more palatable. Examples include sweeteners like sucrose or flavorings like peppermint oil. Additives, thus, play a critical role in optimizing drug performance. They ensure the drug is not just effective, but also user-friendly, enhancing the overall patient experience. Let's summarize what we've learned today about preformulation. It's the preliminary stage in the formulation of a drug, examining factors like solubility, stability, and dissolution. These parameters are crucial in determining the drug's performance and behavior within the body. We've also touched on additives, which are substances added to enhance the drug's properties. Examples include preservatives and coloring agents. Remember, pre-formulation is a critical step in the development of safe and effective drugs. Subscribe for more.